Hello, my name is Hadi Farhangi. I'm going to talk about basics of statistics and introduction. Section 1, data and information. I'm going to talk about what is a statistical variable, what is the difference between data and information, and what is data for statistical analysis. Section 2, measures, visualization, histogram, and distribution. I'm going to talk about measuring a statistical variable, visualizing a statistical variable, histogram, and distribution. Section 3, advanced statistics. I'm going to talk about hypothesis testing, correlation and regression line, and more advanced topics. Section 1, data and information. We talk about a statistical variable. What is a statistical variable? It's a variable that takes different values non-deterministically. What is a deterministic variable? It's a variable whose value is known and can be calculated. For example, x equal to 3 is known or we calculated that. Non-deterministic variable is a variable whose value is not known or cannot be calculated. It can only be observed. I have here home sale data. I have variables price and size, and we have 72 observation, 72 homes that we observe variables price and size. Data versus information. Data is shown in the form of one or multiple statistical variables, while information is numerical measures such as mean, variance, percentages, etc., graphs or tables derived from data. Here I have an example of home sale prices and size of homes, and I have 72 observation, that's data. Another set of data is basketball players. I have 96 of them. We have variable assist, height, time played, age, and point per match. For the information, I have a histogram here, a table. These are not data, these graphs, while these set of observations for multiple variables, they are data. Section 2, measures, visualization, histogram, and distributions. First, measuring a variable. Here I have home sale data. I consider variable size. I call it X. And now I have a bunch of measures for that variable. X bar and mu are mean of variable. X bar if it is sample, mu if it is population. S square and S, they are variance and standard deviation of variable if data is related to sample. Sigma square and sigma are variance and standard deviation of variable if data related to population. X hat is the median of a variable. Q1 is the first quartile, Q2 second quartile, and Q3 third quartile. We will talk about these sample and population in future videos. We will talk about these measures in the future videos as well. Visualizing a variable plot data, I have X, which is our variable. It is the size in wholesale data, and I created a plot. And every observation in this data is represented by a dot, and that dot goes up considering the horizontal line by the value of X. You have to do it for every data. Here I did it for 7 observation in the data. And if you connect these dots together, you will have a line plot. Visualizing a variable, scatter plot. A scatter plot plots two variables against each other. Here I have home sale data. X is the first variable or price. Y is the second variable or size. Here I have the scatter plot. The horizontal line is X, vertical line is Y, and I plotted only 7 observation of my data. You have to do it for all. And every point 1 is the variable X. It shows the amount of variable X in horizontal line, and variable Y, the amount of that, the value of that in the second line. So this is for observation 1. You have to do it for all of these observations. Histogram. We have our variable X from home cell data, and we saw that a line chart, we have a horizontal line observation and vertical line value of X. And for every observation, we record value of X in a dot by going up according to value of X, and we will have a line chart. In histogram, on the other hand, we swap places of these two axes. So in horizontal line, we have ranges of value of X, and within each range, we record how many observations we have. For example, if range of X is 1 to 2, how many observations? We record that in a bar. Between 3 and 4, how many observations? We record it in a bar, and we call it histogram. And as you can see, the axes are swapping places, and we do a little bit more. So once we swap X and observation to get histogram, then for value of X we have ranges, and for value of Y we have frequencies. Frequency distribution, we have variable X. For this variable we had the histogram, and if we connect the dot on top of bars of histogram, we find a new plot that we call distribution. And we will learn about discrete and continuous variable distribution in the future videos. Frequency distribution example, we have home sale data with 2 variables, price and size. For the price, I draw the histogram and I connected the top of the bars via a curve, and that creates the distribution of price. Same for the size. I have the histogram. I connect the top of the bars and I have the histogram of size. These are bimodal distributions. Section 3, Advanced Statistics Hypothesis Testing. We use hypothesis testing to investigate claims. Claims gives alternative hypothesis, and that gives null hypothesis. H0 is the logical opposite of claim, and HA is the claim. We will dive into understanding these settings in the future videos. More on hypothesis testing. Example of hypothesis testing application. First, assume we want to compare the success of children in a single parent family versus children in a two-parent family. This is hypothesis testing of two population proportions. Another example, assume we want to investigate the effects of implementing a new policy on the total sales of an organization. This is hypothesis testing of one population means. Example 3, assume we want to compare the total sale of Walmart and Target. This is hypothesis testing of two population mean. Types of hypothesis testing. 1, population means. 2, population means. 1, population proportions. 2, population proportions. Significance of correlation, fitness tests, etc. We dive into hypothesis testing types in the future video. Correlation and regression. Correlation is the relationship between variables. Regression line, the equation that shows the relationship between variables. Here I have the scatter plot, and there's a green line that somehow shows the trend between these two variables. So correlation is measured by R, and regression line is shown by the green line in the figure. In the future video, we show how to calculate R, how significant R is, and how to derive the formulation of regression line. More on advanced statistics topics such as logistic regression, clustering, principal component, support vector machine, stochastic processes, stochastic optimization, etc. Logistic regression extends the idea of regression line to situation when the independent variable is integer. Clustering creates groups or clusters of the data observations based on their similarity on variable values. Principal component selects the most important variables in a data to define it mildly. Application is in clustering data. Support vector machine provides a hyperplane to separate data based on observations and not variables. Stochastic processes is the study of processes that are stochastic using statistical concepts such as Markov decision processes. Stochastic optimization is optimization under random uncertain parameters. Sounds complicated? Yes, we will learn more about them in the future videos.